Guys, let's do this problem right here. The question is asking, consider the system of linear equation Ax is equal to b, where A is this matrix and b also given. The first question is asking, find the values of alpha and beta such that above system has no solution. So in this case, if you see, the values before alpha are not zeros, therefore we don't have direct control over this. So in order to get control over these things, what I have to do is I have to do the Gauss-Jordan and make these two numbers equal to 0. Then we can decide which number will give the no solution values. So in this case, so first do the Gauss-Jordan. So let's see. So first I'm doing the A part. I'm doing the bringing this matrix down here. So it's going to be 1 0 1 minus 1 1 2, and we have 1 1 alpha, and I'm writing the b opposite to this, so it's going to be 1 1 beta. So let's do the Gauss-Jordan. First of all, I want to eliminate this one. I can eliminate simply by adding with the second row. So let's see. So 1 0 1 1. This is going to be minus 1 1 2, and it's going to be 1. Then if we add R2 plus R3, which will give us 0 right here. Then 1 plus 1 2. Then alpha plus 2. Then beta plus 1. Then I have to eliminate this 2, but I can't directly eliminate it. So what I have to do is I can make this one 0, then I can do something to this one to eliminate this one. So to make this one 0, I can simply add this one with the first equation. So let's see. So 1 0 1, and we have 1 right here. So if I add this one with the first equation, it's going to be R1 plus R2. That will give us 0 right here, and here is going to be 1, and we will get 3 right here, and this is going to be 2. And in the bottom it's going to be same thing. It's going to be 0 2 alpha plus 2, and here is going to be beta plus 1. Now we can eliminate this one by multiplying the second equation by -2 and adding with the third equation. So let's do that. So it's going to be 1 0 1 1, and this is going to be 0 1 3 2, and I'm multiplying the second equation by 2, so it's going to be negative 2 R2 plus R3, which will go 0 right here, and this is going to be also 0. And if I multiply this one by -2, this will become -6. -6 plus 2 is going to be -4. Therefore, this is going to be alpha minus 4, and this will become -2 times -2 is going to be -4, and beta -4 plus 1 is going to be -3. Therefore, it's going to be beta -3. But the question is asking, find the values of alpha and beta. So now we have control over this, right? And we can now find the values. Find the values alpha and beta such that the above system has no solution. So basically, usually if we have to have no solution, these 3 rows should be 0, and we have to have a number right here. That's the thing that's gonna give the no solution. If it's infinitely many solution, it has to have everything 0, and if it's unique solution, this has to be a number, and this can be anything. It can be 0 or anything. Then those are the 3 conditions. So in this case, the no solution condition. No solution condition. This has to be 0, and this has to be a number. So in this case, to make this one 0, if you plug this one 4, that's the only thing that's going to give us 0. So alpha is equal to 4, and to make this one into a number, beta shouldn't be equal to 3. If it's 3, then this will become 0. So it should not be equal to 3. Then if it's not 3, then others are going to be numbers. So therefore beta is not equal to 3. So this is the answer for the first question. The second question is asking, find the values of alpha and beta such that above system has infinite number of solutions. In this case, find the general solution of the system. So as I mentioned before, to have infinite solution, it has to have 0 0 0 0 in the both. All of them should be 0. So in this case, what will make this all of them 0? To make this one 0, I have to add 4. So alpha should be equal to 4. If alpha is 4, this is going to be 0. If beta is 3, this is going to be 0. So those are the answers for this question. Therefore, the answer is alpha is equal to 4, beta is equal to 3. and also they are asking find the general solution of this system. So to do the system, I had to solve this system. So let's see, 1 0 1 1 and 0 1 3 2, and in this case they mean that when we have infinitely many solution gates, so it means 0 0 0 0, so all of them are 0. Now we had to find the solution. So in this case we know this is going to be free variable because we have leading one right here, also leading one right here, but this column doesn't have leading one. Therefore this is my free variable. So set let's C is my free variable. C is free variable. So C is free variable, and now I can solve the system. So I had to write everything in terms of free variable. So in this case, let's create the equations. The first equation is going to be x plus, so this is x, y, z. So that's how I'm taking. So this x plus z is equal to 1, x plus z is equal to 1. The second equation is y plus 3z is equal to 1. So in this case, the first equation is going to give us x is equal to 1 minus z, and second equation is going to give us y is equal to 1 minus 3z. So I have to write everything in terms of z. So the final answer is going to be, we write in terms of x, y, z. So it's going to be 1 minus z is my x, and 1 minus 3z is my y, and then final z is going to be c because it's a free variable. And that's how the final answer comes out to be, and that's how it's done. I hope you guys liked this video. See you next time.